We've had high interest in this webinar. We did have an earlier one with really high attendance, and this is a really high quality, lot of value with the information that you'll get today from this presentation. On tap, I have Greg Simon. Greg is my counterpart over on the professional team, and really glad he is the guy who can tell you about this more than I'll ever be able to. So very glad to have Greg today. Greg, thank you very much. I don't want to waste time with my rambling, but I just want to welcome everyone. Thank you very much. I'm going to turn it over to Greg. Greg, thanks for hopping on.
I appreciate it. So I'm going to go ahead and share my screen here.
Greg, can I interject while you're doing that? I am going to monitor the Q&A, and as I do that, go ahead and add your questions to the Q&A tab, and know that don't think you're being ignored. What we're going to do is try to hold some of your questions toward the end, because the presentation covers a lot of ground, and most likely your questions will be answered in the process of the presentation. So we'll try to hold most of the Q&A toward the end of the meeting, but do go ahead as we run through, add your questions, because at least we're aware of them. So thanks so much. Sorry.
Yeah, all good. So obviously you guys are here to hear a little bit about Spectera. I will say there is so much that is new and different about this system that we're not able to cover it all, but we'll try to get through as much as we can, and it is a lot of information. So I'm just gonna preface that. So first and foremost, what is Spectera, right? So we say it's the world's first wideband bidirectional digital wireless ecosystem. That's lots of words. What it really is it is wireless microphones and wireless in-ears, IFBs, in the same device, up to 64 channels in a single rack unit. And I will get into a lot of details as to how that all works, and not only how the technology works, but also like how you're able to do that and what the different parameters are when you do this. So first and foremost, this is a fully bidirectional communication system, meaning every single aspect of this system has two-way communication between your mobile devices and your base station system antennas as well. So not only do we have full remote control, so there is no other channel or separate piece that's doing remote control. This is all happening within the actual channel itself, and not only can we send data back and forth for controlling headphone volumes and mic gains and all sorts of other stuff, but we can also have audio going in both directions in that same channel, meaning that not only can we have mics and IEMs in the same rack device, but we can actually have them in the same mobile device as well. So first and foremost, let's show you the body pack, which is we call it the SEK. And this is a mic transmitter and an IEM receiver in one, and it can do both of them simultaneously. So you can do it just as a mic, you can do it just as an in-ear monitor, or you can do it both at the same time. So that's definitely something we couldn't do with previous technology, and I'll get deep into why this new technology is very different than what we've done for the last 80 years, and how we're able to do that. So we have an endless encoder on the top there. We have your 3-pin mic instrument or mic input with a LEMO connector. We have a standard headphone connector, 3.5 millimeter. That has a brand new headphone amp that was designed specifically for this system. It is by far the highest power headphone amp we've ever put into a wireless. It's dual 350 milliwatt. If you look at any of the other ones, about a dual 100 is about the max you'll ever see. This is way more, which means it gets super loud, but it also means when it's at real world volumes, it is super clean. It's also fully impedance matching to the headphones that are plugged in. It can even detect if the headphones are plugged in or not, even if they're partially plugged in, and it sends back a message to the software saying, hey, one of your headphones got unplugged. We also are going to have this available in 2 variants. So right now we have it available in the UHF variant, and then we're also going to have it available in a 1.4 gigahertz variant. That's going to depend on the region that you're in and what the regulations are. Do know that in the UHF version, there is only one frequency range. So there aren't different frequency ranges. There aren't different SKUs that you have to worry about. If you're in the UHF range, if you're in the US, you're going to get the full 470 to 608 plus the gap up above. If you're in EMEA, you're going to get 470 to 698 with a small exception in the low 600s. And depending on the region that you're in, it will vary there, but there's only one version of the pack, the antennas and the base stations. And actually the base stations, the antennas, or the base station's capable of doing both variants in one. It's just the antennas and the packs that are different from 1.4 to UHF. We also have an e-ink screen on the display. So that's like very similar to like a Kindle. So when you can have the name, you have battery life, you can have headphone level, and when you take the battery out or turn it off, all of the information that you want will stay on the screen, even when there's no battery in there. This is the same technology from our EWDX system, and it also uses the same battery as EWDX. So we have the BA70 battery. It is a lithium battery. It does not work with AA as it uses too much voltage. But it's the same battery as EWD and EWDX. And even next year when we come out with the handheld, and I know the first question is always, when is the handheld coming? It's coming middle of next year, sometime around the August timeframe. That will also use the same BA70 battery as well. So as we move forward in the Sennheiser ecosystem, all of our digital wireless devices will start to use the same battery and be fully interchangeable between each other. Other important thing to note about the pack. So it is a 3-channel pack now, right? So traditionally, you're either using one channel for a mic, and that's a 1-channel device, or you have like one channel for an IEM, which might have your left and right signal kind of squished together on that one channel. With Spectera, it is actually 3 separate channels. So you can use one channel for a mic, or you can use one channel for an IFB, or you can use 2 channels, a mic and an IFB, mono, or you can use 3 channels for a mic and a stereo IEM, but it is actually discrete mono channel. So it is much better separation. The audio quality is exponentially better than what we were able to do before because you have discrete channels. But when you are designing a system, you do have to keep that in mind. How many channels, in which mode do I want to be and how many channels do I get? And how many channels is each pack going to use? So you need to kind of suss that out. You can also obviously use it just as a stereo IEM and not the other ones. One other thing that I do want to address, which we talked about earlier, is we always get the question, are you going to have one that's just a mic or one that's just an IEM? And when we did the initial analysis on these devices, we said, well, if we make a third of them mics, a third of them IEMs, and a third of them both, the cost is actually quite expensive to do that. But if we made all of them have both, the cost of manufacturing was actually lower. And so we were able to make one device that did everything and keep the price at what individual directional devices would have been. So that was a super big help there. Another big change with the Spectera system is the architecture. It is dramatically reduced in terms of what you need for rack space and shipping and cables and all of this other stuff. So I always love showing this picture. So on the left, you have a 16 microphone and 8 stereo IEM setup with our traditional or previous narrow band, top of the line stuff. You have a multi-zone combiner. You have a combiner for the IEMs. You have, a pair of mic antennas, you have an IEM antenna, and you have all of your mobile devices that you need. On the right, you have an equivalent system. In one rack space, we have 2 antennas, which we usually recommend, though you don't necessarily need 2 antennas depending on the scenario, and a lot less mobile devices as well. But this isn't quite a fair picture here because on the right, we're only showing 32 channels. You can do 64 channels with the Spectera system, but I couldn't fit all of that stuff on the other side. So it's a real shift in what we're doing. If you are, shipping or moving around with this system, I actually fly now with a up to 64 channel. I usually have 16 packs with me on an airplane. I check it and I can bring the entire system with me. Previously, to do that, you would need a freight truck or you need to freight the system. And so here comes the big question. How are you able to do all of this? And why weren't we able to do this before, right? And really what is changing now is we are using a very different technology called WMAS, or at least WMAS is the framework of a technology. And we are using a 6 or 8 megahertz wideband carrier, which is completely different, right? So just for reference, depending on the region you're in, the regulations have now been changed. So in most countries, almost all countries, it is now legal to do a wideband carrier. So before the last couple of years, and depending on where you are, the laws changed differently. Like in the US, it changed in 2024. You were only able to have a wireless microphone go up to 200 kilohertz of width. Now, in the US, we can go up to 6 megahertz. In Europe, we can go up to 8 megahertz. And so you'll have the choice of either a 6 or 8 megahertz carrier, depending on where you are. And so if you have a US device or something with a US license on it, it will only be able to do 6 megahertz. If you have one that is in Europe, you'll be able to do 6 or 8. And the laws are up to 6 or up to 8. So if you have a European device, you can use it at 6 megahertz in the US. And if you have a US device, you can also use it at 6 megahertz in Europe. So those are able to be used back and forth. But due to the regulations, the devices have to be, when they're sold into specific countries, they have to be limited to what that is legal in that particular country's regulation. And so the question is, well, why this wideband carrier, right? What's the difference, or what's the advantage? And what we learned from our top-of-the-line Digital 9000 system, and really from every narrowband system, is they really struggle with a phenomenon called multipath phase cancellation. And that is the phenomenon where the signal goes all over the place. And sometimes it goes directly into an antenna, and sometimes it bounces off of a wall and hits that same antenna at a different timing. And maybe it's out of phase with itself, right? And now the signal strength, because it's out of phase, drops pretty dramatically. In this little video that was here, you can kind of see, it's a little choppy, I apologize about that, but you can kind of see at certain frequencies, that signal strength can drop dramatically for a moment in time. Right? This is why with a traditional system, you have to have 2 antennas, and they have to be in 2 different locations, because if you only have one, when this happens at that frequency, you will get a dropout, because you could lose 40, 50 dB of signal with phase cancellation. But what we learned was this is only happening in a relatively small part of the spectrum at any moment in time. And if you had a carrier that was big enough, well, yes, part of that carrier would maybe get destroyed by multipath. The whole thing will not. These things can be up to 2 megahertz wide, these phase cancellations. And so if you have something that's much wider than 2 megahertz, you can essentially get around the physics, right? So to be clear, we didn't solve physics, we didn't change physics, but we have kind of a way of getting around it. And one more thing I want to be clear on is Spectera isn't a big carrier, right? It's not we have a small carrier and now we have a big carrier. It's actually hundreds of very small carriers all interleaved next to each other. And I'll show you a picture of that in a second. 2 other big points that happen here. So because Spectera is using time slots, meaning one microphone is sending out all of its signal over hundreds of carriers at the same time. Many of those are copies, which gives you a very high level of redundancy. Then after that moment in time, it stops transmitting. And the next one starts transmitting, and back and forth, right? And so each microphone and each IEM travels for a small moment in time over hundreds of carriers, so lots of data for a short burst. And it means actually only one of the devices that you're using. So if I have a Spectera system with 24 microphones, only one of those microphones is actually on at any moment in time, which means that the power density on your stage is exponentially lower. So let me give an example. If you are on a stage and I have 10 wireless microphones, and those 10 wireless microphones, narrowband, are each using 50 milliwatts, the energy on my stage is now 500 milliwatts, which brings the noise floor up. It makes it much more difficult for other systems to work. That's why the more channels you have, the more difficult it becomes to make a system work. With Spectera, if there are 10 Spectera packs on a stage, only one of them is on it at a given time. So if I have 10 of them, each at 50 milliwatts, the total energy on the stage is only 50 milliwatts. And so we're able to have a much cleaner environment. It makes it a lot easier to make other systems work. And actually, you can put a narrowband right next to a Spectera system, and they can both operate no problem. You can actually put a narrowband on top of the Spectera system, and while the narrowband probably won't work, the Spectera system will just see it as multipath interference. It's destroying some of my subcarriers, but I've got lots of copies, so I'm okay. Can actually do that with up to 2 of them at the same time. Another thing that's really important about what these systems can do is because they are bidirectional and communicating all the time, we can also have the packs, or in the future the handhelds, only transmit when they are in full sync or lock with the system. Meaning if I take one of these packs to my buddy's stage, I can't take out their RF because I'm not transmitting, I'm only listening at that point in time. And last point I'll make here, because this is a ton of points that I just made, is the fact that all of your microphones within a single RF carrier are on the same center frequency. So they're not all technically on the same frequency. They're all spread between those frequencies. They're spread out over that. But your frequency coordination becomes exponentially easier. For every Spectera system you have, all of the wireless microphones or IEMs or both that are within that use one frequency to coordinate. And so you can do 1 or 2 or 3 or 4 Spectera carriers, as simple as looking at a scan going, I'll put one here, one here, one here, and one here. And that could be your whole frequency coordination for 256 channels. And if you've ever done a 256 channel frequency coordination, but it's not usually that easy. Also, if you're combining it with narrowbands, whatever, you can see Spectera as if it were a DTV channel, and it makes it much easier there as well, even if it's not all Spectera systems. So here is a little bit of like an artist rendering. This is not a Spectera carrier, but it's a little image that I came up with to kind of show what a Spectera carrier sort of looks like. And it's these hundreds of subcarriers all spread out within the 6 megahertz. And so when something happens to a few of these, it's okay. And that's what makes this system so much more resistant to dropouts, is what makes this system so much more robust and more reliable, is the fact that you're not on one frequency. And if that frequency gets messed up, you're in trouble. You're on hundreds of frequencies at the same time. And a lot of them have to get screwed up in order for your system to have an issue. So it really increases the reliability dramatically because you're sending out on hundreds of frequencies at the same time. Here's a little more on the multipath. So this is actually image of 200 kilohertz, 1 megahertz, 2 megahertz, and 6 megahertz carriers. And as you can see, even up to 2 megahertz, the dip from multipath can be dramatic. So in order to really achieve true mitigation of the multipath fading, you need to be at really a minimum of 6 megahertz in order to get that, right? Technically, you can get around it a little bit smaller, but then you don't have much space left for all of your data and channels. So 6 is really the minimum, and that's why we're at 6. And any system that's doing 1 or 2 megahertz doesn't overcome that multipath fading really almost at all, and therefore it still needs to be true diversity, and it also is going to suffer from this wideband power density. So you're actually the wider it goes, the less power you get, and until you overcome the multipath, you don't actually see a benefit there, or at least not much of a benefit. So this is actually the venue that they first found some really massive multipath. Maybe it's not the first time, but it was a venue that we had some really major multipath issues in. And it is a gigantic space. They build cruise ships in here. I think those cruise ships in the background were in here. And this was the site of the Eurovision Song Contest in 2014. And we did, and this space is gigantic. And so this was sort of our test case of almost no wireless works in this building, or it doesn't work reliably anyway, just because the reflections are out of control. And so this was our test case of, if we build a wideband system, it should perform better in this space than narrowband. And what we found in this space was it didn't just perform better. With this amount of reflections, reflections were our enemy, and now with Spectera, they became our friend. And so in a space that has massive amount of reflections, Spectera will outperform any narrowband by a wide margin. Some prototypes that we have there. I've got a little video I'll play for you. So it's maybe a minute long, not even, of Jonas kind of walking around in the space.
And here you can see in here, it is packed up with containers. And in the very far end away from here, 150 meters, that's actually where we have our antenna standing. Let's go for a small walk. We can take a detour around here. You see here, there's 6 layers of stacked containers. I have nothing that resembles anything like line of sight. And still I have rock solid reception. Let's see.
Do we have a little video of
Bicycle, bicycle,
the back?
bicycle. I want to ride my bicycle.
We did a lot of tests. That was with the Doppler, so we can make sure that even at higher speeds, the system is working. That video, by the way, goes on for the full length of that song if you want to watch him ride around on a bicycle for 7 minutes. Really, it overcomes the most major issue of narrowband wireless, which is the multipath mitigation, which means if you have a reflective space, Spectera will have coverage far beyond what a traditional system would have. And if you have no reflections, it might be similar or maybe even a little less than a traditional narrowband system because it is lower power. Now let's talk about the flexibility of the system itself, right? So in your standard wireless microphone system, or pretty much every wireless microphone system you're familiar with, when you buy the system, it has a certain audio quality, it has a certain latency, and it has a finite amount of battery life, and that's sort of what it is, right? And a certain number of channel counts that you can get within a space. And if you want something very different, you purchase a different system, right? And that's where you kind of decide which system you want to buy based on those features. Well, with Spectera, now that we have this really big chunk of data, we can do different audio link modes. And those audio link modes can use up different amounts of this large carrier, right? So with narrowband, you have finite buckets. They're all about the same, right? We can only do so much data with a narrowband system. And so every mic and every IEM gets around the same amount of data. If they're all the same system, they'll get exactly the same amount of data. And you get one of each, right? And that's it. With Spectera, you get this giant bucket of data, and now you can split it up however you want. Meaning, I can use less data per channel and get way more channel count than I could ever get with narrowbands in the same space. Or I could use more data than a narrowband, and I could get way lower latency or way higher audio quality than I could ever get with narrowband. And with Spectera, you get to choose this for every microphone and every IEM individually, even if they're in the same pack. So I want to say that one more time. For every single IEM and for every single microphone, you can choose how much data it is using. And once you use up all the data, then you have to make another channel. So you get to choose, do I want it to be roughly equivalent to the systems that are today with similar latency and similar audio quality? Spoiler alert, Spectera is lower latency and better audio quality than all of those, even in that setting. But do I want something they're all roughly the same? Or do I want my lead singer to get the lowest possible latency on IEM and his mic to be, PCM 2496, and then maybe my techs will get higher latency because doesn't matter what the latency is, right? Now I can divide up that channel however I want versus it is what it is. So again, there are 11 different modes, and we can go through some of them quickly, but I want to give some reference points. So each one of these modes can use anywhere from a little bit less than 1% of the channel, all the way up to about 12.5% per channel as well. So, but for reference point, if you want something that is lower latency than Digital 6000 with higher audio quality than Digital 6000, so arguably, and I know I'm biased, but arguably Sennheiser Digital 6000 is the best sounding wireless microphone you can buy on the market today. It may not have the most features, but it's the best sounding wireless in my opinion. At 32 channels in a single carrier, you can get lower latency and higher audio quality than Digital 6000. You can run 2 carriers on a single base station, and so you can get 64 channels at higher audio quality and lower latency than Digital 6000. So it's not 64 channels with crap audio or super high latency. It's 64 channels at better than 6K latency and better than 6K audio quality. Now you can choose to go way higher, right? You can say, well, I don't want, a little under 3 milliseconds. I want 1 millisecond of latency. Well, I can do that and use up more data. Or I want 2496 uncompressed PCM audio, which no narrowband can do, at all. So you can choose that, but you could also choose that just for one microphone. You can also say, you know what? I don't really care about the latency because it's just for some speech, or it's going to video and there's 30 milliseconds of latency in the video, so it doesn't actually matter what the latency is. Well, then I can actually get even more channels within a single RF carrier. So it's up to you to decide what you want to do. Two things to note there. For the IEM side, if 2 packs are listening to the same mix, they do not use 2 resources. They only use 1. So you could have 50 packs on the same mix, and that counts as 1 mix or 1 channel of audio or 2 channels of audio if it's stereo. So that doesn't use any additional. And the channel itself, because we have to have two-way communication, there is a limit to the number of packs that you can do. So with previous systems and analog systems, I could have 1,000 packs connected to the same mix. Now you'll be limited to 128 per RF channel Again, you can do 2 RF channels per base station, but so far we haven't had anyone run into that limit of 256 packs. That's also like $500,000 worth of packs. So, if you have that problem, you call us, you let us know. We'd be happy to help. But it is a limitation that, you should at least be aware of. Now let's talk about how low the latency can be or the audio quality. So one thing I want to be very, very clear on is there are 3 audio codecs in this system. It's really only 2 codecs because PCM is not really a codec, it's just no codec. Then we have CDAC, which is better than our Digital 6000. So it's actually the same codec from Digital 6000, but it has been enhanced. It has a little bit more data, so less data compression. And there's some other stuff that they did with dynamic range and processing in order to make it significantly better than Digital 6000. We then also have the Opus codec. Now, this codec is only available with some of the really high latency modes. So it would be used for, not live performance where you're listening back to yourself, or if you're going to video. The audio quality is not as high as the CDAC, but we do have some of these Opus some systems using the Opus setting, doing things like Broadway shows. So the audio quality, even at the very lowest setting, is spectacular, but that's all relative, right? So I don't want you to ever think that, oh yeah, I was using Spectera, but I had to have low audio quality. There's no such thing as low audio quality with Spectera, but there are different levels of it. And then you go all the way up to PCM, which is fully uncompressed. You can do 2448 or 2496, depending on channel count that you need. And then for latency, the IEM, so for the live stereo IEMs, the latency ranges from 0.7 to 2.7 milliseconds, with most settings being somewhere in the 1 to 2 millisecond range. So there's 0.7, 1.1, 1.6, and 2.7 milliseconds are your options on a stereo IEM. On the mic side, for live performance, we have 1 millisecond, 1.1, 1.6, and 2.7 milliseconds as well. And then there are a couple of modes that have 10 and 15 milliseconds, but again, those would only be used for video applications or speech applications where you're not listening back to yourself in real time, really where the latency doesn't matter. Then you could use those modes, and those modes have some exceptional channel counts and or coverage areas as well. One other thing to point out here is that there are 3 different audio interfaces on the back of the base station. We have a Dante interface, and then we have 2 MADI interfaces. So you have 2 card slots. You can put either optical MADI cards in them, or you can put coax cards in them. We left it as a card slot because half the people said I have to have coax, the other half said I have to have optical. So we left them as card slots, so you can get whichever cards you need and then run them redundantly with 2 of either one. You could do 1 of each if you wanted as well. And each one of those audio interfaces can be run at a different sample rate at the same time. So if I wanted to run redundantly 48K Dante to one console and 96K MADI to another, I can do that with Spectera, and Spectera will handle the sample rate conversion without having to do anything on the other side. All right, let's get into another thing about this system that has changed dramatically, and that is your antennas. So first things, the antennas are continuously scanning, and I mean all the antennas. So the antennas on the packs are every 8 milliseconds you're getting a scan, and the antennas that are connected to the base station, every 8 milliseconds you're getting a scan. And what I mean by that is every 8 milliseconds, this whole entire system mutes. There's no audio muted, by the way, but the entire system mutes for a few microseconds, and then a scan of the space is done, meaning you can get real-time information about what is under your carrier. And you can actually see in the web UI, like if there are interferers that pop up and exactly what frequency they are, and if they're higher on one antenna than another. So you can even say, hey, the stage left antenna just sees something at 404.2 megahertz. We should figure out who turned something on to the left side of the stage. So you can kind of see all of that and mitigate all of that and theoretically triangulate it. We don't have a way of doing that in the system yet, of triangulating where this interference is coming from. Another big thing with the antennas is they are the first, what we're calling digital antennas. So the whole antenna is obviously not digital. Analog RF signal is coming into the antenna, but then it is being digitized at the antenna, meaning there is no RF signal that is coming out of this antenna. It is data that's coming out, and so there's no more coax, there's no more boosters, there's no more splitters, there's no more combiners. You don't have to calculate cable losses, none of that with this system. And remember, this one antenna is your mics and your IEMs. So that one antenna replaces those 3 antennas you were using before. And now you can use extra antennas for a more robust system, for redundancy, for zone extension, for multi-zone, or for multiple carriers. So we'll talk about that in a minute. So first things first, the antenna is powered over PoE. That PoE is supplied by the base station, so it has 4 ports on there, which I'll show in a minute, and it is powered over PoE. It is standard PoE, and the cable length is up to 328 feet or 100 meters. We've done a few that were a little bit longer, but that's the recommended length for the cable. You can extend it with fiber. It is not RF over fiber, it is data over fiber, but these are layer 1 proprietary signals. So you can't put it through a switch, and the converter needs to be one of the approved ones that we recommend that are layer 1. They're relatively inexpensive, but they don't have any sort of switching system in them at all. And then with a fiber converter, you can extend from 328 feet up to 4,000 meters, just somewhere around 13,120 something feet. So you can put them very far apart from each other if you want to. So you can do that. You will have to add a standard PoE injector. It's not PoE plus or anything else like that, just a standard PoE injector if you're using fiber. If you're not using fiber, you don't need that. And you can mix and match. You could have all 4 antennas over fiber. You could have 2 on fiber, 2 on coax, or whatever combination you want. Also, there is IP54 protection on these antennas, which is good. So again, no, you cannot put them through switches because they're layer 1 proprietary. The reason we did that, by the way, was because we had to make a trade-off. If we could have made it go through switches, but then the latency for all of the everything would go up, right? Because now you have to wait for the switch to be able to do that. And what we decided was it was more important to have ultra low latency on the IEM and mic side than it was to be able to go through a switch. So we had to make that choice, and we chose to get the latency as low as possible.
Hey, Greg, real quick question.
Yes.
Raphael wants to know that are there any options for extending the antennas over 100 meters via CAT cable? So I know we've got the option of going to fiber in between, but any other options other than fiber to get past that 100-meter mark?
Not that I'm aware of, mostly because, the copper's only rated for 100 meters. So like, I don't believe so. I think you would need to do fiber over 100 meters.
Okay, thank you.
So let's talk a little bit about how this system kind of picks up, right? So I don't want to get too deep in the weeds in terms of coverage, but a traditional narrowband system, this is digital, but it could be any system. You have 2 antennas, and each of those antennas are switching back and forth with your true or switching diversity to whichever signal is better because of multipath, right? One of them is going to have a bad signal at some point in time because of the multipath phenomenon. And so what does that mean? That means each one of these antennas must cover the entire stage, right? If one of these antennas only covers half the stage, then when that becomes the dominant antenna due to multipath at the other antenna, you will get a dropout on the other half of the stage, right? So each antenna has to cover the whole stage. Now, how do we make sure that they cover the stage? Well, we need to make sure that our noise floor is low enough that our carrier is high enough where the difference gives us enough coverage for the entire stage, right? And what happens if I go on a frequency that's pretty noisy? Well, then my coverage goes down. And what if that frequency being noisy means I only cover 70% of the stage? Well, then I can't use that frequency because I can't cover the whole stage, right? And this seems relatively simple. So I have to find a cleaner and cleaner frequency until it gives me enough coverage for the entire space that I'm trying to cover. With Spectera, that's not necessarily the case, right? Because now you can run multiple antennas redundant of each other. So technically, you only need 1 antenna to cover the stage. It's getting around multipath, so it doesn't technically need to have a second antenna. I want to put that caveat, and the reason I say technically is because we always recommend 2 antennas for almost every system. If you have a very small space, 1 can be okay, but for robustness, for body blocking, for things like that, we always recommend 2. It's much safer, and honestly, the cost of an antenna versus the system is almost nothing. We recommend minimum at 2 antennas, but also show you why even more antennas is better. So what does that mean? That means if I add a second antenna, I'm going to overcome some wideband fading, and now I'm going to have redundancy. But it also means that if I operate on a higher noise floor, maybe each antenna only covers 70% of the stage. But if I space them apart, put 1 on each side of the stage, I'll actually have full coverage of the entire stage, and I'll have some area in the middle that is redundant zone. So it's being covered by 2 antennas at the same time. So this is a major advantage of Spectera. It also means that Spectera can operate on higher noise floors because while it's no different than a narrowband system in terms of what it can cover, you know, other than the reflections part of it, I can now operate on a higher noise floor because it's okay if I don't cover the entire space, because I can put up a second or a third or even a fourth antenna to cover the entire space. I can also then do something like put 4 antennas, and now if each one of my antennas is 30 times diversity, I have 4 antennas redundantly covering the stage. I essentially have equivalent to 120 times diversity, and I'm still trying to get this to catch on, but I don't think it ever will. But according to ChatGPT, that is dodecacontraversity. So let's try to remember that. I don't think it's going to stick. But anyway, it allows you to kind of do that. But you can also use antennas for zone extension. So there's no reason I can't cover different areas or extend the distance of the coverage by putting out multiple antennas that way. Now let's get into the base station itself. So the base station has redundant power supplies. So they're fully redundant to each other, and they're running simultaneously, so you can plug them both in. If one of them fails for whatever reason, the other one takes over without any audio interruption. You have 4 antenna ports. So these antenna ports can be either all on one RF channel, they can be split across 2 RF channels, or any one of these ports can be turned into a real-time analyzer, and that antenna will switch into real-time analyzer mode, and then you can switch it back into channel 1 or channel 2, depending on what you need. An antenna can only do 1 channel at a time or scan, so keep that in mind. You've got word clock I/O, you've got network control, you have a cascade port. So the cascade port is really there, so in the future, we can have more than 4 antennas on a single RF channel, or we can maybe have more than the 32 by 32 I/O that exists on the box. So that is another limitation of the box, where you have 32 inputs and 32 outputs. So your 64 channels needs to be split between mics and IEMs if you're going to go above 32. So you can do up to 32 mics, you could do up to 32 mono IEMs at the same time, or 16 stereos, because remember the stereos are discrete mono channels. And the Cascade port will allow us in the future, and we're hoping to have the first iteration of Cascade port for a 10 extension sometime late spring. And that will actually give us the ability to go beyond 4 antennas. What I will say, though, is if you are doing multiple RF channels, today, you can buy a base station. If 4 antennas covers the space that you need, which is a gigantic space, by the way, but you need more capacity, you can do a second base station, put up another 4 antennas, a third base station, put up another 4 antennas, fourth, fifth, sixth, however many you have space in the spectrum for, and you can get more and more carriers. There's no need for cascade. Actually, I would recommend not cascading them at that point, because the cascade would then link them all together, and they would be less independent of each other. So really the cascade will give us the ability to say, I want to cover the stage with 2 antennas, and I want to cover the green room with an antenna, and I want to cover front of house with another antenna. Oh, and I have a B stage that I want to have 2 antennas, and I have another studio down in the basement, and I have, right, and now the cascade will allow us to go to, huge spaces over a single RF channel. Other things that are important about Spectera, it is fully AS256 encrypted, so both the audio and the control is encrypted through and through. It all means that it is impossible for somebody to show up to your show or show up to your venue with a Spectera pack, tune it to the same frequency, and listen in. That's not possible. It needs to be paired to the system in order to do that. Also, all of the devices within the system are fully synchronized. They have to be in order to the time slot, but it also means we can synchronize the audio, which means that if I have multiple microphones, they're actually phase coherent now. And if I play back multiple IEMs at the same time, they're also phase coherent, meaning that I could theoretically do a wireless immersive system with packs. I don't know why you would do that yet, but you guys come up with the cool stuff, not us. And then you could theoretically capture audio in phase. So next year when the handheld comes out around August, I plan to put a pair of them over somebody flying through the, on their drum set, and then the cymbals can be in phase as Tommy Lee flies through the stadium wirelessly, which will be super cool. A few example systems that I have here, and then I want to take you into the web UI itself. So these are really just to show how really small and easy the system is to do. So if I have somebody calls me and says I need 8 mics and 8 stereo IEMs, it can be as simple as a base station, a couple of antennas, and 8 packs. Done. 3 SKUs, it's done. If they say, well, actually now I need 48 mics and 48 stereo IEMs, IMs with 32 individual mixes and multiple zones, and I need a continuous scan. It's still the same 3 SKUs, it's just more of them. So it's so easy to put this together. And even in this can fit in a relatively small case to do a gigantic show with this. So very, very cool. Now I'm going to take you a little bit into some pricing. So I will have a caveat here. All of the pricing that you see here is retail map pricing for the United States. So if you're in a different country, obviously some of this may vary, but we can only pick one, and that's what I live. So I picked that. And the whole point here is not to go through all the pricing of the system, right? But it's really just to point out how much per channel it's going to cost you based on scaling. Because the thing that's different about Spectera is that with all of our previous systems and our competitors' previous systems, in general, if I get 8 channels and then I say I want 16, it's about twice as expensive. And then I say I want 32, it's about twice as expensive, right? With Spectera, that's not necessarily the case, right? So price per channel changes depending on what you're doing. So this system here is 8 stereo IEMs. You get 1.1 milliseconds of full digital discrete audio. You get a huge coverage area, and you'd be in the $3,600 per person retail price range. If we go to 16 channels, well, we can do that all within one RF carrier. We can go up to 1.6 milliseconds. We can still get a very large coverage area, and now our price just went down to $2,800 per stereo mix. If we go to the mic side, it's the same thing. So this is literally a copy of the first slide with the same prices. It's all the same. It's the same system, but shows a slightly different latency picture of 1.0 instead of 1.1 because the mic is a little bit lower on this side. If I go to 16, same thing. I'm at 1.6 and I'm back to this price point here. So again, scalability. Now, we price this based on the assumption that many users are going to want to use this only in one direction. They're going to want to use it as a mic. They're going to want to use it just as an IEM. And if it's priced for the person who's using both, then all of the people who want just one, it's going to be, out of range. And that was not the key for what we wanted to do. So, well, here's one more 32 mic, goes up to 2.7, and now you're in the $2,400 price range. But if we go bidirectionally, now this is the same exact system that we had on the first slide. But now we're talking about 1.6 plus 1.6 milliseconds. So 3 milliseconds round trip between your IEM and your mic, which doesn't exist, by the way, on a narrowband today, except for some of the old analog stuff. And then your price per channel goes under $2,000 per channel. Again, retail pricing. If you go up to 16 and you're okay with 5 milliseconds of round trip, which is pretty similar to what you're getting today on your top end stuff, you can be under or around $1,400 per channel. So all of a sudden the price point for this becomes very, very low, depending on what you're doing. Of course, you can add some extra antennas to add extra zones. I don't know if you've ever done a wireless multi-zone before, but if somebody says, hey, I want to add a zone, it's usually a lots of zeros scenario and lots of cabling and very time consuming. Now it's go grab another Ethernet cable and another $1,500 antenna. And you can add another zone or another large zone or 2 small zones just by adding that very easily. And again, this is just the beginning. So this whole thing is an ecosystem that we're going to build, from the starting point of the bidirectional body pack, the base station, and the antenna, which are all available now and have been shipping for 6 months already. And that came obviously earlier in 2025. The next thing we will come out with hardware-wise is a handheld. I've actually got a prototype right here. So that's going to come out around the August timeframe. We're also going to work on command mode, ST2110. We'll have the Cascade port coming, hopefully late spring next year, and then even an engineer mode where you can switch between on the IEM. So we're going to continue to build out this ecosystem. We even have a smaller body pack that'll be coming out at some point after that that may have 2 mic inputs because now we can do multiple channels in the same device. So there's a lot of stuff that's going to happen within this ecosystem. So I want to spend about 5 minutes, just a little overview, kind of showing the actual web interface and kind of take you through it. And then we'll go through some questions, which I'm sure you guys will have a lot of because I went quite fast. Okay, let me go ahead and share a different window here. All right, so hopefully you guys can see that. So this is the web interface. I'm gonna make it a little bit smaller. And this is actually showing my system here. I've got a whole bunch of packs connected to this at the moment. And then what you can actually see here is these are my RF channels here. I have one on 497 center frequency. It's at 50 milliwatt. I have 3 antennas attached to it at the moment. Then I've got another one here at 569. I can open this up and actually see what my noise floor is under each of these. So these are minus 95. This one's a minus 81 because it's on a DTV channel right now, or some sort of noise floor. I'm not sure what it is. Might be because it's sitting on top of the rack. And you can actually choose these by going to your frequency scan. So I can go to a frequency scan. Actually, let me put one of these in scan mode here. We'll put these guys in scan mode. And I will do a frequency scan. And this is actually going to show me a full frequency scan of the area. And what's really cool is I can say, all right, well, this 479, that looks nice and clean. So I could put 32 channels there if I want. This 485 is nice and clean. I could put 32 channels. This is the channel I'm on right now. I have this channel, this channel, this channel. So it's really that easy to do frequency coordination now. I can just pick a DTV that's empty and I can put all my mics there. If I need to put it on top of a channel that's noisy, I can probably put up enough antennas to overcome the noise floor there as well. You can obviously select your antennas. So I want to put that antenna back on channel 1, put this one on channel 2. And then down here, I have all of my my packs. So I have the ability to see my signal level, my mic side here, my IEM side here, as well as my link quality indicator. So this will actually show me how many, if I'm getting full data or if I'm getting close to a dropout or something like that. You can see that on all of the different devices individually as well. On the right here, we have our headphone detection. So you can see this one is blue because that says my headphone's plugged in. This one is red, which is because my headphones are unplugged. And so that's probably the number one reason somebody gets a dropout is because they, have a headphone get unplugged. That's usually the number one reason for that. So you can actually see that inside the software as well. So that's a brief overview. We do have an audio levels page, so you can see all the audio inputs coming in and out of the system. We have an I/O page, so you can actually do routing. You can go to dark or light mode. I'll kill you guys with the light mode, but you have the ability to switch back and forth between that. And there are going to be more advancements coming with the web interface or the web UI as well. In order to get to this, it's just HTTPS semicolon / and then the IP address of your device. And actually the device is a full web or HTTP device. So we are going to have an API coming early next year. And I even have a, kind of a Stream Deck device sitting on my desk now that I have using Companion, controlling all sorts of different things where I can, change frequencies and I can change all sorts of stuff via third-party control. So all of that is coming, and the open API will be available next year. So I feel like I went through a lot, and I'm sure there's a whole bunch of questions. So I wanted to leave the last 10 minutes to kind of see if I can address as many of them as possible.
Thanks, Greg. Just off the top, I have Gabrielle, and he asked the question, is there any roadmap for telemetry on mics, specifically with the ability to report coordinate data with real-time OSC?
So at the moment, I don't have any information on when that would be, but it's all stuff that's possible with this system. Now that we know exactly, if now you can have multiple antennas and we know exactly the signal strength at any moment in time at each antenna, it's something that could be developed.
Okay, thank you. Raphael has another question. Looks like the antennas have changed from logic periodic, example as like a AD3700, to Yagi Uda type. Looks from the pictures, is this correct? And if yes, would you know the reason or advantage for this?
So the answer is no. They are still standard log periodic, but they have holes in them now because what we found is you don't need to fill in the whole thing. And when they're flat, they actually become a little bit of a kite and wind tries to blow them over. And so we put those slots in there. Same with our ADP UHF. So it's actually coming straight from the ADP UHF. With that said, because we are now utilizing reflections instead of being hurt by reflections, the pickup pattern and the way that you deploy antennas is dramatically different. And just for an example, in a reflective space, we tested an Omni version of this antenna and the coverage was almost the same. So a lot of the things you know about different antenna types kind of goes out the window when you're utilizing reflections instead of being hurt by them.
Someone would like to know, what is the engineering mode?
Yeah, so engineering mode is the ability to switch, and we have this on our 2000 series, but basically if I have 10 different mixes, I can go into engineering mode on one of my packs and jump between the different mixes that exist in the system. So an engineer can listen to the guitar mix and then the keys mix and the vocal mix just from the pack, being able to switch around.
Awesome. Raul would like to know, early in the presentation, you mentioned that technically only one pack is transmitting at a time. How does that work with multiple mics that are all performing simultaneously?
Yeah.
Yeah.
Easy. So you can have up to 128 within the RF carrier, and only one is going at a time. But they are so fast that we can stream together real-time audio. Now, it does add to the latency, right? So doing that adds to the latency. The good news is we were able to have the system be so fast that the latency can still be, even with that number of channels, under a millisecond.
Awesome. Vincent would like to know, what is the minimum signal-to-noise ratio for the packs and handhelds to communicate with the base?
So that varies based on the mode that you're in, which is actually why we didn't get into this, because we didn't have quite enough time in this webinar. But each mode has a different coverage amount, and we have like 4 different levels of coverage based on that. And the reason for the different coverage is they use different modulation schemes, and therefore they need different amounts of carrier to noise. So in your, let's call it, extended modes, it's somewhere in the 10 or 11 dB type range. But again, remember, you're utilizing reflections, so that's the reflections are adding to that, not taking away from that, like they do in narrowband. And in the very complex ones, it's in the low 20s.
Right. An anonymous attendee says you've done a great job, and they didn't say you're good looking, but I think that was a part of it. All right. So next is John asked the question: what is the muting system like when one does get a dropout?
Yeah, so in the last firmware update, we've actually enhanced that pretty dramatically. So that's available as of a week ago. And it's very similar to a traditional narrowband now, where if it does drop out, it's just silence for that moment. It's very fast to come back.
Okay. Gabrielle would like to know, phase coherence often implies some amount of latency penalty. Is that true with this system as well?
Technically, yes, it is. But again, it's in the microseconds.
Okay. Last question that I have here is from Gabrielle again, and is Milan compatibility on the roadmap?
Not at the time that I'm aware of. So I know SMPTE 2110 is kind of next. We have Dante and Maddie, of course, now. And then, but again, well, I don't know if I said this on this webinar, but we want feedback from you guys. Like, what is important? Like, what do you need? Like, is Milan more important than a handheld? Because we could put that first, right? So obviously that was a silly question. We know the answer to that one. But in general, like, what's important? What do you want first? And our team can move the order around of what is most important in that scenario.
Great questions. That's all I see right now, Greg.
Amazing. Well, cool. If you guys have anything else, we can hang out for a couple more minutes. I hope that was helpful. I know there was a lot of information in there, so I think there'll be a recording if you want to go back and check it out.
Oh, they're popping in. We've got 3 more.
Well, wait a minute.
Is the latency specified inclusive or Dante latency?
I actually believe it is including the Dante latency at 1/4 millisecond.
Okay. Keith says, does one base handle up to 8 packs?
One base handles up to 256 packs and can be up to 64 channels of audio, depending on how you split it up.
Awesome, Rafael. Thank you. Will the slides and recording be available? The recording, I think, will be available.
I don't think the slides are public, but the recording we'll have available.
Okay. Russell said, great to see innovation. Tim said, where can a recording of this be found in the future? Let me find out about that. I'll have a list of all the attendees today. And if any information I have, I'll send out a subsequent email to everyone. Can you tell us what shows on Broadway use these?
No. I don't. It's not. I'm not at liberty to say. So I don't know that we can. But there are some active shows currently.
There are some broadcast agencies using them as well. PGA station is using them, among many others now.
Yeah, PGA has actually been using like one of the first systems, and we did an article on it, so I know we can talk about it. But they've been using one of the first systems actually since December, and it was a very interesting story because we gave them a prototype. We said, play with it, try it, like use it. And then 2 weeks later, they said, we're going live on air with it. And we went, whoa, it's a prototype. I don't know if we're comfortable. They said, this system has dropped out 0 times, and all of our other systems drop out all the time, so we want to use this live on air. We went, okay. And they've been doing that ever since January 1. So
very cool. We have 1 more minute for questions. I don't see populated at the moment. By the way, that is a real piano behind Greg. It's not just a backdrop. So, beautiful piano. I guess that's it. Anything last thing you want to say, Greg, before we hop up? Oh, any system tuning done with the packs yet?
Not sure what you mean by that. Everything is, the whole system goes on a single frequency, right? And then they all sort of go back and forth.
Any case studies that have authorized their name to be shared to use this technology?
Yeah, we have on our website like a handful of articles that are there. PGA is one of them. There's a few others as well. I just don't want to say something I'm not supposed to say.
Yeah. Gabrielle asked speaker alignment with measurement mics. Some of the...
Yeah, so on our roadmap, we do have a plug-on transmitter, but there's absolutely no reason you can't plug a measurement mic right into the pack. It's definitely going to be the flattest, most linear, with the least amount of data compression possible. You can actually run it again PCM, so there would be no effect to the audio in terms of the data, in terms of codec. So you could do that now with a cable into a pack.
Can this be used with software like Smart?
Yeah, that's the same. That's basically the same question. And yeah, absolutely. I will also say the EWDP plug-on transmitter is quite phase linear as well. And that's obviously at a very different price point than Spectera. I think the transmitter itself is like $379.
So Vincent said we used it for our host live on the Tony Awards this year with great success over 3 zones. Amazing product. Nice endorsement, Vincent. Thank you. Can the system scan be... Can the system scan and look for a frequency from being interfered with?
It is doing that all of the time, and it will read back that to you in real time. So all the time it is scanning on all devices and all antennas. And then actually in the software, you can see all 4 antennas. And if one of them is seeing some rogue frequency, it will tell you that that's happening and tell you how it's affecting it as well.
Excellent. All right. Well, it's the top of the hour. Wait a minute. Keith has another part of the question he was asking. He said, what he meant was, can you lock or secure the frequency?
So not entirely sure what you mean there. Obviously, it's impossible to stop a rogue system from using that same frequency on top of you because you don't have control over their system. But the system itself will lock onto a single frequency. All the devices will lock into that frequency. I'm not sure. Maybe if you want to give me an email, Keith, and we can kind of go into that deeper. I'm not sure exactly what you mean. And so the system won't auto switch to a new frequency. That's maybe what you're talking there. But you can very easily type in a new frequency, and all of the devices will move to that frequency. There is a downtime of 3 to 4 seconds. So it's not something I do mid-song, but if you're having, major RF issues where you would have dropouts all over the place, you could move everything within a few seconds versus tomorrow.
I'm going to put your email and my email address in the chat. Well, it's not letting me. So it's greg.simon@sennheiser.com, and I am steve.wingo@sennheiser.com. Cool. Well, thanks, everyone. Have a great rest of your day. Thank you for your time. I know you're busy. If you're in the U.S., hope you have a great Thanksgiving time next week. We appreciate you very much, and you're amazing. So thanks so much. Take care.
Thanks.